So here we are with another question on diode connected circuits. So again, this circuit, like the previous one which we discussed, it is a very simple and straightforward circuit, but it can be used to implement one very important logic circuit, logic gate, which we'll discuss about. So first let us solve the simple and straightforward thing which is asked here to calculate the output voltage. We have two silicon diodes. Nothing has been mentioned about whether they are ideal or not. So we have to consider that they are not ideal. The built-in potential is 0.7 volt and we have to determine the output voltage. So here if you look at diode D1, okay, diode D1, the P end is connected to 10 volt, the N end is connected to 10 volt. So I've already said that when you consider non-ideal diodes, if both ends are connected to the same potential, then it will not be enough to drive the diode into forward bias, because the built-in potential, it will not allow it to. So in this case it will be off or open circuit. This one, P end is connected to plus 10 volt, N end is connected to 0 volt. It will be sufficient to turn it on. We'll replace it with its built-in potential, that is 0.7 volt. So let us redraw the circuit. So it is something like this. It is 10 volt, open circuited. Here it is 0 volt and it will be like this, 0.7 volt. Then we have 10 volt, 1 kilo ohm and this V0. So here a current will flow like this, I, and it is 10 minus I into 1 kilo ohm, okay, minus 0.7 equals to 0. That implies I is equal to 9.3 milliampere. Okay, I is equal to 9.3 milliampere. Now if we want to calculate V0, the KVL equation will be from ground to V0, so it will be 10 minus 9.3 into 1 minus V0 equals to 0. That implies V0 is equal to 0.7 volt. Okay, this is the solution, which is very simple and straightforward, basic circuit analysis technique and basic knowledge about the on and off condition of diodes. Okay, now this circuit involving diode and resistors, it is actually a 2-input AND gate. Okay, a 2-input AND gate. Now we know how the truth table of AND gate, we have discussed it in digital electronics, basic concepts about all the logic gates. You can check out all the videos by checking the digital electronics playlist. So AND gate truth table, we all know that the inputs, let's say x1, x2 and the output to x1, x2, 0, 0, 0, 1, 1, 0, 1, 1. Okay, in all the cases it is 0 and only this case it is 1. So how it can be done using this circuit? So again, for simplicity, we will cut this built-in potential part, this 0.7 volt part, because it will unnecessarily lead to a lot of calculations. We'll assume that the diode is ideal. Okay, to simplify the discussion, diode is ideal means when it is on, it is short circuit, when it is off, it is open circuit. Okay, so this condition here in when we implement it for logic circuits, the supply voltage, it is considered as logic 1 or high, which is called, and the ground or 0 volt, it is considered as logic 0 or low. So positive logic. Okay, there is also a negative logic, but now let us stick to it. So here this condition 10 volt and 0 volt, it means that this one is connected to logic 1, this one is connected to logic 0. So here this is off, it is open circuited, this is on, it means it is short circuited. So let us replace it with short circuit. Okay, so this one is short circuited. This one is short circuited. Now here V0 is directly connected to 0 volt here. So it means output is 0 volt. In another way, if you want to do it, it is also that here the current which will flow, if we apply KVL, it will be 10 milliampere. Okay, it will be 10 milliampere. 10 by 1 kilo ohm, it will be 10 milliampere. So if you apply KVL also, V0 minus this V0, it will be like this. V0 plus 10 minus 10, it will be 0. Okay, 10 milliampere into 1 kilo ohm is 10. Okay, this 10 milliampere into 1 kilo ohm, that will be 10 volt. So V0 plus 10 minus 10 is equal to 0. That implies V0 equals to 0. So either way, if you see, the output will also always be 0 volt, that is low. So which is this case, 1 0, it is 0. This case. Let us take the other one. Okay, this is 1 and this is 0. Okay, this is connected to 10 volt and this is connected to 0 volt. 10 volt, 0 volt, logic 1, logic 0. So it means here diode D2 will be off. Okay, diode D2 will be off and this one will be on. Okay, here diode D2 will be off because both of them are connected to the same, and this one will be on. On means it will be short circuited, off means it will be open circuited. Okay, so this is the thing. This is 10 volt and this is 0 volt, opposite. volt, 0 volt. So here a direct short circuited path is connected from this point V0 and 0 volt. So V0 equals to 0 volt. And the other way also, a current of 10 milliampere flows, and if we put KVL, we will get the same result, V0 equals to 0 volt. So the output will be 0 volt, which is low, which is this case. Logic 0, logic 1 gives to rise to 0. This. Okay. Now if both the inputs are equal to 0, both of them are equal to 0, let's say. Okay, it is also 0 volt, the logic 0, and the other one is also 0 volt. So in this case what will happen is that both the diodes, okay, both the diodes, they will be on. Both the diodes will be on. Why? Because both of them have their P ends connected to a higher potential and the N end is connected to 0 volt or ground. So both the diodes will be on. So either way there will be a short circuited path in between 0 volt and the output point. Okay, this. So here also there is a short circuited path that can be connected to 0 volt, and this point also there is a path by which it can be directly connected to 0 volt. So the output again will be 0 volt. Okay. So this condition 0 0, that also gives us to logic 0. Then the last one, both are connected to logic 1 or high, that is 10 volt supply voltage. This is connected to 10 volt and this is also connected to 10 volt, logic 1, logic 1, 10, 10. In this case, both the diodes will be open circuited. Both the diodes will be open circuited. Okay. So this one goes out of the question. This one also goes out of the. Okay, this, both are open circuited. Now in this case, no current 0 milliampere flows through this 1 kilo ohm resistor, because there is no connection between this 10 volt and ground. There is no such connection, no current flows through this 1 kilo ohm resistor. So here V0 is simply equal to 10 volt. If we apply KVL, it will be V0 plus 0 milliampere into 1 kilo ohm minus 10 is equal to 0. That implies V0 equals to 10 volt. This. So here V0 equals to 10 volt and this is logic high. This is equal to logic high. VCC 10 volt is logic high, logic 1, 0 volt ground is logic low, which is this condition. So in the previous question, we discussed how diode circuits can be used to implement OR gate. In this, we discussed how it can be implemented to to create a AND gate. So the basic circuit was very simple. The question which was asked to find out V0, that was very simple, but the main concept here was to make you understand how it can be used to implement different logic gates. So don't worry, we'll discuss about all the, it is a very vast area, implementation of logic circuits using various electronic devices. Like I said, it can be implemented using diodes, it can be implemented using MOSFETs, it can be implemented using BJTs. So there is a lot of thing to it. Here just I wanted to make this discussion a little bit interesting, so that's why I inserted this. Okay, so we'll discuss about that logic implementation in the digital electronics section, so don't worry about that. So here, just to make the discussion a little bit interesting, I inserted this concept. Okay, so here we discussed the logic implementation of AND gate using diode circuits. Okay.